Well, here we are again. So in order to make the watch videos over the winter, I think I'm going to need a video lamp, because I was just reviewing some of the last videos and they were a bit dark. I have decided to modify this and turn it into a video lamp. Partly what we've got here is an old fluorescent tube fitting. So this is an Allen key on the base, and I think that's to adjust something on the arm. So what we've got inside is typically a mains lead, which comes to here, goes into this board here. It doesn't seem to have a rectifier, although there are diodes on this thing. And then if you measure the voltage coming out here, this is not DC, it's about half a volt DC or something like that. But if you put it on the AC range on the meter, you get about 12 volts AC coming off here. I'm not sure what frequency that is, but I think to drive a fluorescent tube you do need AC, so I don't think there's DC coming off this. So my plan for the video lamp is to use diodes, so we need a DC supply. So I was raking around in my enormous box full of wrecked pieces, and what I found was this. So this is a wrecked road torch. I took the electronics out of it because I kind of like the diode array, and I thought I could possibly use that for a video light, but I think I might use this. So on here there's a little circuit board, and from what I can see, most of that is a flasher circuit, because it's a road lamp, so you need to turn it on to flash sometimes. It looks to me like, so there's a central bulb, there's a 9 LED array, and there's a 20 LED array, and there's a mode switch, probably, which switches the flashing or straight on and off, and there's an on and off switch. It's a bit overcomplicated. The battery that I took out of this was a 6 volt lead acid battery, which kind of tells you how old it is. So the plan is to get this onto here somehow. Unfortunately, I looked high and low, I have lost the bit that goes around the outside there. So I'm going to find a piece of plastic to put on there. I'm going to try and use the old wires, but they are very short, unfortunately. So I don't know if I'll be able to do that or not, but we'll give it a shot anyway. As far as this, I'm going to save this and the resistor for it, but the rest of the flashing gubbins and that I probably won't do much with. That'll probably just go into the bucket, which you just saw a few minutes ago, and we'll keep all the switches and things like that. The next job really is to find a bit of plastic which will allow this to use these screw holes to mount that, and then we need to get this off out of there, and we're going to use the same mains lead. So I found this is an old Sony Ericsson power supply, and it doesn't say 6 volt, actually says 4.9 volts, which is nearly 5 volts, and I haven't got a 6 volt one at the moment, but this is 700 milliamps, and the testing that I've done on the 9 LED array, which is just here, I got 3 volts at 0.2 amp. So this unit should have enough oomph to power this without getting too hot, and it's also got star drivers on it, which means you can take it apart quite easily without having to contend with glue and stuff like that. So I would like to use this original lead, but that does mean having to thread it through the lamp, and I don't really want to do that. So that should give me a pattern. There you go, perfect. This is just like being at school, eh? Where you draw around things. But you know, it's a legitimate way to get things done. I wonder if using a pair of scissors might work actually. Oh, it does. Yeah, look at that. So unfortunately I have lost the original pieces. It's like a lens that would go into there. Like so. So I'm just going to do this video just to illustrate to people just how easy it is to recycle things rather than just chucking them away. So here we have one plastic piece, got some screws for it. There's a bit of a bump at the back there, you can see there. I can actually take this off, but there's an option to put another LED bulb in the middle if I need to. So I'm going to leave it on, and then we'll screw that onto there. I was going to recess it a bit more, but it doesn't actually matter if it's recessed or not. It makes no difference really, and I'm not really too worried about how it looks because it's more a functional object. So I now need to drill some holes just at the back here. 1, 2, 3. There are 3 screws already on this PCB. So we'll put some little spaces in there. We should be able to mount this directly onto the plate. Right, so should be able to. The thing is, there are lots of holes in the top of this, so I think what I need to do is kind of make sure we know which ones we're aiming for. So of course I can't see those from the other side, which is really stupid. Duh. Right. Shell. Might need some slightly longer screws, but let's see. Oh, they're long enough. Alright, so we've got that on there. The leads, I'm just going to snip them off. So that should be free now. What to do now is connect this to this. Now this is pretty short, so I might have to do a bit of work on that. What we have here is the driver socket for the LED. So that one says 20 LED, and if you count those, that's 20 LEDs. And that one says 9 LED, if you count those, 9 LEDs. So that is the resistor then to drive the 9 LED. So we're going to whip that off there. You just loosen the solder and pull it. It's not really that tricky. Bit harder to do on video. There you go. Off. Okay, so the next job I think is to get this wire a bit further up. I don't know if we're going to get this open, but I'll certainly give it a go. Looks like it's a snap fit, but it's not coming off that easily. Oh yeah, oh, there you go, look. Well, so the plan is to actually pull that out through there a bit, but it's not really happening just now, so I'll have to do a bit more. There, so you can see the reason why. There's a cable guide in there. So we pushed it through. We have to leave some slack in the system because it's a flexible lamp, so you need that extra wire for that reason. And I guess the manufacturers have probably calculated that exactly. What I'd really like to do, in fact, I'm on in two minds, is to just take the cable off, just put the Ericsson thing in there completely. In fact, I might just do that. In fact, I am going to do that. So we have this Sony Ericsson PSU. So before I go to assemble this, I am going to test if there's actually anything coming off it, because that would be a travesty, wouldn't it? So we are at nig to nig, pulse to pulse. So we're getting 5.65 volts. So I'm hoping that we can just put that through there, and then it'll just appear at the other end. Whoa, look at that! Yes! That's a result! Bit of flux on there. So there's a little symbol on the PCB which very clearly says negative. That's where your negative goes. And then there's a one here. And that's where your positive goes. So we pull this through. Put some screws in it. Don't know if it was necessary to undo that, really. This lamp was originally made by ROHS, which I'm pretty sure is China. Just those bits there need cleaning up, and put that cable grommet back. Right, so there's a little packing piece in there just to help that. The wire's going to go down there like that, and then this bit's going to go back on, which is a snap fit. So we now come to here. So we are going to connect the 4.5 volts using this, and if you remember, I have to put that resistor in there as well to drive the LEDs. Okay, this is what's inside the little Sony Ericsson unit. These two pads here they connect to those two. So that's the mains AC that goes onto there. So we need to solder some wires onto there. And that's your DC out, just which we've already tested, so that's fine. Oh yeah, so we got this board off. I'm going to do a bit of soldering. We've got this ready. This is out of the Sony Ericsson. So you can see there's like a slotted piece there. So the screw has got like slots on it. And that goes on the other side. And then we have this fancy Allen key thing that they gave us. So that's your wire coming through. Right, so that's the old AC unit, which drives like a neon bulb. Neon bulbs are pretty expensive, and it's not faulty, it's just coming off. Alright, so that's our resistor put onto a wire. Alright, so now we've got the wires soldered on. We can now snip off the old lead. No longer needed. Okay, so this is our little Sony Ericsson board, 4.9 volts, which seems to be delivering about 6 really, and I've got mains coming in, which was there before. We've now soldered the mains onto the two pads, and that black one there is from the live, from the switch, and then we now need to put the resistor, which is the pos, and that which is the neg, onto here, and then connect this. So we need to leave a bit of slack for the lamp to operate, because it's a flexible lamp. Okay, so when you drive a single LED, you subtract the LED's on voltage from the total power supply, and then you use V over IR to get the current. So LEDs are not, the brightness of LEDs is not driven by voltage, it's driven by current. So you set the current with the LED. Now if you've got 9 in parallel, essentially you can drive 9 with one resistor. That is perfectly fine, but you need to multiply the current for one LED by 9. and then make sure you calculate the wattage that's required of the resistor. And since this was already in the road lamp that we took this off, and it should be correct. Right, so in theory that should switch on now. So now's the moment when it blows up. Just kidding. So that is on. Well, hey, look at that. Yeah, brilliant. So there's a bit of a delay there because there's a couple of capacitors in the output, I think. Okay, there you go folks, that completes our little video-like conversion. Hope you enjoyed that little video. So I should now be able to make my watch videos with a bit more light than we had before, and hopefully I won't need any 10 quid bulbs to put in the damn thing. So it doesn't really matter what it looks like, it's mainly a functional object. So anyway, that brings us to the end of this little video. Thanks so much for watching folks, bye.